In this class, I'm going to look at geometric progression. After this, I'm going to dive into a lot of questions, okay? Let's start. What is a geometric progression? A geometric progression is a specific type of sequence where each term after the first is found by multiply the preceding one by a fixed non-zero number called the common ratio. Okay? Like arithmetic progression, a geometric progression is a specific case of a sequence, but it follows a multiplicative rather than an additive pattern. Okay? Instead of adding, as you saw in arithmetic progression, for geometric progression, you have to simply what? Do multiplication using the common ratio. We're going to see all that, okay? So what is the formula for geometric progression? For geometric progression, it says to get any of the term, you simply say AR n minus 1, okay? It means the first term multiplied by the common ratio raised to power the term minus 1. For instance, I say I want the fifth term, but I know the first term to be 1. I must also know what? The common ratio. Once I have all that information, I should be able to substitute those information in this place. Okay? Now let's look at an instance. Look at this. It says, find the seventh term of the geometric progression this. So the first thing you need to do is to get the common ratio. How do you get the common ratio? Before, when we are looking at the common difference, we say this minus this. For this time, we're going to say this divided by this, okay? It means, therefore, to get the common ratio, we say 12 divided by 4, which is equals to 3. As you can see, the first term is 4. Here is 4. So, to get the seventh term, we use AR n minus 1, which is, let's call this one n, which is the seventh term. The first one is 4 multiplied by 3 raised to power 7 minus 1. 4 multiplied by 3 raised to power what? 6. You agree with me? This equals to 4 multiplied by, what is 3 raised to power 6? That is 7 to 9. You're going to have 2916. Okay? That is the seventh term for this geometric progression. If you want to get the common ratio, which is one of the most important things, simply divide this by this, or you divide this by this. Okay? The term divided by the previous or the preceding term. Okay? Then this is A, the first term. Then you can substitute. Okay? Let's look at this. It says the first term of a geometric progression is 6. That is, A is equal to 6. And its common ratio is 3. Common ratio is 3. Find the sixth term. We should find the sixth term. The formula says any term is equal to AR n minus 1. Okay? So therefore, if you substitute all this here, it means we are looking at the sixth term as equal to 6 multiplied by R, which is 3. Then this 6 2 minus 1. Then 6 multiplied by 3 raised to power 5. The next thing you ask yourself, what is 3 raised to power 5? This is 243. Okay? If you multiply this, you're going to have 1458 as the system for this geometric progression. Okay? Let's look at this. It says, if this, and this are consecutive terms of a geometric progression, find value of y and s, the GP, the 42nd term of the GP, leaving your answer in index form. Let's see. The first thing we need to do is to write down the formula, which says for any term Okay? What is A? The first term here is this. But because the question is asking us to find Y, we are going to only use the common ratio. The common ratio between these two is the same thing with the common ratio between this and this. Because if you want to get the common ratio, either you say this divided by this or this divided by this. You will still have the same answer. Therefore, we're going to say the common ratio is y plus 6 over y plus 2. Or we say r is equals to y plus 14 over y plus 6. Okay? With this now, because this and this are the same, we can equate this and this. That is to say, this is equals to this. That is to say, y plus 6 over y plus 2 is equals to y plus 14 over y plus 6. Okay? Now we can cross multiply to have y plus 6, y plus 6 equal to y plus 2, y plus 14. Now let's work on this. This and this will give us y squared plus 6y plus 6y plus 36 equal to, this is y squared plus 14y plus 2y plus 28. Okay? This will give us y squared plus 12y plus 36 equal to y squared plus 16y plus 28. Okay? You agree with me that if I move this to this side, this and this will just strike out. Okay? To have 12y plus 36 equals to 16y plus 28. You also agree with me if I move this to this side now, I will have 16y minus 12y. While I move this to this side, I have 36 minus 28. Okay? You agree with me that if I do this, I'm going to have 8 as equal to, this will give us 4y. And divide both side by 4, y therefore is equals to 2. Okay? So we have the value of y now. And it says hence the GP, the geometric progression. So let's do that. With the knowledge of 2 as y, we can calculate the GP as y, which is, you can see here 2 plus 2, that is 4, 2 plus 6, that is 8, 2 plus this, that is 16, and so on and so forth. So this is a GP. Okay? The next one is the 42nd term. That is, this 42nd term is equals to ARN minus 1. So, you agree with me that the first term is this, that is 4. Multiply by the common ratio. You can find it from here now, the common ratio, okay? That is R. So the value of R here is equals to 2 plus 6 all over 2 plus 2 equals to 8 over 4, which is equals to 2. So that is 2 raised to power. This is 42. 42 minus 1, which is 4 multiplied by 2 raised to power 41. Okay, we need to solve this further because we are asked to leave our answer in index format. What is this? This simply means 2 raised to power 2 multiplied by 2 raised to power 41. Because they have the same base, so you can see in this place, we take 2 plus 41, which is equals to 2 raised to power 43. So this is the answer we are asked to get, okay? Hope this is understood. Thank you for viewing. Let's look at it. It says the first and third terms of a GP are 1 and 9 respectively. What is the second term? Okay? Saying The first is 1. The third is 9. Okay? It's asking us to find what? The second. How do we go about this? You know the formula says, okay? Now we have the first. Let's use this one first. So the third is equals to the first multiplied by the common ratio, third minus 1. We don't know the common ratio. It means this is r raised to power 2. So what is actually the third? The third is 9. Okay? So you agree with me, I can rearrange it to be r squared equals to 9, which is r squared equals to 3 raised to power 2. Because these index are the same, it means the base are also the same. Remember in our indices class, if you have not watched those videos, go to this channel and look for them. There are so many, okay? We treated all this. Therefore, we can boldly say r is equals to 3. Because we now know r, we can come back for this to say the second term is the first term, which is 1, multiplied by r, which is our 3, 2 minus 1, which is 1 multiplied by 3 raised to power 1 equals to 3. So 3 is the second term, okay? Hope this understood. Thank you for viewing. Look at this. It says the first, that is, the first is 3, the second is 6, and the last one, which we don't know, is 1536, respectively. Okay? Calculate the number of terms in the GP. The number of terms in the GP is this n. So before we come here, let's first of all use this guy. That is the second term. The second is equals to AR second minus 1, which is the first one is 3 multiplied by R. This is 1. What is second? Second is 6. We cannot divide both sides by 3. Before that, let's just bring this to be 3R. Divide both sides by 3. R, therefore, you agree with me, is 2. We now have R as 2. Okay? Now that we have R as 2, we can come back to this place to say n we are looking for is actually equals to this. That is 536. Okay? Is equals to AR. A is what? A is 3. What is our R? R is 2. Then we come back and put this n minus 1. So that is 1536 is equals to 3 multiplied by 2n minus 1. We are looking for n. We divide both sides by 3 first. Just to remove this 3. If you divide this one now, you have 512. That is to say 512 is equals to 2n minus 1. Okay? Because I saw 2 here, I asked myself, what is 2 in terms of 512? That is 2 raised to power 9. 512 is 2 raised to power 9. It's equals to 2n minus 1. Because the base are the same, we have seen this in indices class. You can go and watch those videos. Therefore, the power are also equal. So therefore, 9 is equals to n minus 1. So n, therefore, move this to this side, is 9 plus 1. You agree with me? N, therefore, is 10. So it means the number of terms we are asked to look for is 10. Okay? Hope you understand this. Thank you for viewing. Let's look at this. It says, given that all these are the first 4 terms of an exponential sequence, that is geometric progression, find in simplest form the 8th term. The 8th term. Okay? From what we have here, you can deduce that our A is going to be, or it is, the square root of 6. The second term is 3 square root of 2. So with this information, we can find the common ratio. Okay? Let's find the common ratio. So we know now that this is equals to 3 square root of 2 equals to AR n minus 1. What is A here? A is the square root of 6 multiplied by R, which we don't know. The 2 minus 1. Okay, now we put this one back in this place. And you agree with me that this is square root of 6 multiplied by R, because 2 minus 1 is 1. So no need to put the 1 here. We retain this one. Okay? Now, to get R, we divide both sides by the square root of 6. This and this will cancel. It means R, therefore, is equals to 3 square root of 2 all over square root of 6. All we have to do now is to apply our solid knowledge to work on this. We need to rationalize the denominator by multiplying the numerator by the square root of 6 and denominator by the square root of 6. It means, therefore, we're going to have 3 square root of 2, square root of 6. 6 will be here. 3 here 1, 3 here 2. It means, therefore, this is 12 over 2. That is square root of 12 over 2. If you want to work further on this, we can come up with this as 4 multiplied by 3 over 2. And you agree with me that when you have this is this over 2. What is the meaning of this? This simply means 2 multiplied by the square root of 3 all over 2. This and this will cancel. It means, therefore, we have the square root of 3 as our final answer for the common ratio. Okay? Now that we have the common ratio as square root of 3, we can come here to find the what? The 8 term. So the 8 term is equals to AR 8 minus 1. What is A? A is the square root of 6. Square root of 6 multiplied by R is what? Our R here is the square root of 3. That is square root of 3. This is 7 already, okay? 7. Because 8 minus 1 is 7. Now, how do you solve this? That is this. Let's work on it. Let's work on only this. This one simply means the square root of 3 multiplied by 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 the square root of 3. Let's count. 1, 2, 3, 4, 5, 6. Remain 1. Multiply by the square root of 3. This 2 will give you 3. This 2 will give you 3. This 2 will give you 3. I know the answer offhand, but I just want to explain to you so that you will see me do something. Say, what have you just done? This is alone. So, because it has no partner, we leave it. This will give us 27 square root of 3. Okay? So, therefore, this can be rewritten as the square root of 6 multiplied by 27 square root of 3. Okay? It means 27 multiplied by square root of 6 multiplied by square root of 3, which is 27 multiplied by, this 2 will give us what? The square root of 18. What is 18? 18 means 9 multiplied by 2. Okay? It means, therefore, this 27 multiplied by square root of 9 multiplied by square root of 2. Okay? Which is equals to 27 multiplied by 3 multiplied by the square root of 2. This alone will give us 81 square root of 2. So this is the final answer, 81 square root of 2. Hope you understand what we have done in this class. Okay? You can look at it just step by step, then you get your answer. Okay? Now let's look at this. It says the second and the fourth term of a AP are 10 and 40 respectively. Okay? Find the 1 common ratio, 2 first term, 3 eighth term of the series. The second of a GP is 10. The fourth is 40. Okay? Find the common ratio. We don't know R. So with this now we can do something. Let's start with the formula that says this is n minus 1. For this one now, R is 2 is AR2 minus 1, which is AR raised to power 1. We can leave it like that, but we put 10 here. Let's go for the second one. That says 40 is equals to AR 4 minus 1, which is AR raised to power 3. Call this one equation 2. Call this one equation 3. Okay? With this now, we can find, say here, let's find A. A here is equals to 10 over R. So we can come here and substitute for A. To say 40 is equals to 10 over R multiplied by R raised to power 3. 1 here, this is 3, that is 10 R raised to power 2, put 40. Divide both sides by 10. You agree with me, we have 4, that is R raised to power 2 equals to 4. Then R is equals to the square root of 4, which is 2. Okay? So you can see in this place, which is 2. Okay? Now that we have the common ratio, we can find the first term. The first term is A. So we can come back here to find A. A is 10 over R, which is 2, which is 5. So it means A is 5. Then we find the 8th term. The 8th term is ARn minus 1, which is A5 multiplied by R, which is 2, 8 minus 1, which is 5 multiplied by 2 raised to power 7. If you solve this out now, I'm going to have 640. So this is the final answer for what? For the 8th term. Okay? Hope this is understood. Thank you for viewing.